Hello everyone, welcome to another video on the nomenclature of organic molecules. In this video, we will be discussing how to name carboxylic acids according to IUPAC system. So carboxylic acids are molecules with a carbonyl group that has a hydroxyl group attached on one side. So if we have a carbonyl group, a carbon-oxygen double bond, it will have a hydroxyl group on one side and a hydrogen or any alkyl group on the other side. So this whole functional group forms the carboxylic acid functional group. Now let's see how we can name carboxylic acids according to IUPAC rules. Before moving on to the IUPAC rules, you must remember that carboxylic acids are ranked higher in priority than other functional groups such as carbon-carbon double bonds, carbon-carbon triple bonds, alcohols, ethers, amines, halides, ketones, aldehydes. So if such functional groups appear in the presence of carboxylic acid, then carboxylic acid will be the major or the parent functional group. In other words, the name of the compound will be according to the carboxylic acid functional group. So let's start how IUPAC names carboxylic acids. So the first rule, of course, is to select the longest possible chain with the carboxylic acid functional group. The numbering in this case will always start from the carbonyl carbon of the carboxylic acid, because you have a hydroxyl group on one side of this carbonyl carbon in carboxylic acid. So it will always be the carbon number 1, or it will always be present at one end of the carbon chain. So that carbonyl carbon of this functional group will be your carbon number 1, and because it has higher priority in terms of nomenclature, then the numbering will always start from the carboxylic acid functional group. Now to name the molecule, the last E of the corresponding alkane is replaced by oic acid. So you have a carbon chain and we have a name for the corresponding alkane having similar number of or same number of carbon atoms. So the last E of that alkane is replaced by oic acid. So it becomes generally alkanoic acid. And we will see this with the help of some examples. Like you can see here, we have one carbon atom in this molecule. A carboxylic acid functionality is there. So a one carbon alkane is named as methane. And so the last E of methane is replaced by oic acid, making it methanoic acid. Its common name is formic acid. If we have a 2-carbon chain, so a 2-carbon alkane is named as ethane, but in this case, because we have a carboxylic acid functionality, so the last E of ethane is replaced by oic acid, making it ethanoic acid. The common name for this molecule is acetic acid. If we have a 3-carbon chain, then the name of the molecule would be propanoic acid by replacing the last E of propane by oic acid. And if we have 4-carbon chain, then the name would be butanoic acid. If we have a 5-carbon chain, then the name is pentanoic acid, hexanoic acid, heptanoic acid, octanoic acid, and so on. Now, if this carbon chain having the carboxylic acid functionality is substituted, it has some substituents attached on any carbon atom in the chain, then you have to identify the number and types of substituents. Numbering will not be disturbed because the carbonyl carbon of carboxylic acid will always be your carbon number 1, but you have to identify the type, which means the name of the substituent, and of course you have to mention the number or the position of the substituent as well. So if we have this molecule, you see a carboxylic acid functionality here. This molecule has two chains, 1, 2, 3, 4 carbon chain and a 3 carbon chain. So you have to select the longest chain that has this carboxylic acid functionality. So it's a butanoic acid, but this chain is substituted by a methyl group. So you number the carbon atoms in the chain, starting from this carbonyl carbon. This methyl group is at carbon number 2. So this is a 2-methyl butanoic acid. This is a molecule with two different substituents on the carbon chain. First, you have to select the longest chain. So we have 1, 2, 3, 4, 5 carbons in the chain with the carboxylic acid functionality. So it's a pentanoic acid with a hydroxyl group at carbon number 3 and a chlorine atom attached at carbon number 2. So if you have different substituents, then you mention them in terms of their alphabetical order. So chlorine comes first, then hydroxyl group. So this would be a 2-chloro, 3-hydroxy pentanoic acid. So you see chlorine is at 2, hydroxyl group is at 3. So it's a 2-chloro, 3-hydroxy pentanoic acid. Now you may have double or triple bonds in the chain. So you have to mention their positions while naming the molecule. If you have a ketone or an aldehyde functional group in the chain, then as I have told you earlier, they have a lower priority as compared to carboxylic acid in terms of nomenclature of organic molecules. So carboxylic acid will be the parent functional group, and ketone and aldehydes are treated as substituents in this case, and both of them are named as oxo. So if we have this molecule, see carboxylic acid functionality again with a 4-carbon chain, but this time we have a double bond. So it's not a butanoic acid, in fact it's a butenoic acid, but you have to mention the position of the double bond. So starting from here, the double bond is at carbon number 2. So this would be 2-butenoic acid or but-2-enoic acid. You can name the molecule in both ways according to IUPAC system. If we have this molecule, you see a carboxylic acid functional group again with a double bond in the chain, and now we have a ketone functional group as well. But because ketone has a lower priority, it will be considered as a substituent and written as oxo. So first you have to mention the substituents and their position while naming the molecule. So starting from here, this ketone functional group is at 4. So we have a 4-oxo, and we have a double bond at position 2 in this 5-carbon chain. So it's a pentenoic acid, but it's a pent-2-enoic acid because at 2 we have a double bond, or you can write it in this form, 4-oxo 2-pentenoic acid. So both ways it's okay. Here's an example of a molecule with a carboxylic acid functionality, a ketone functional group, an aldehyde, and a hydroxyl group. Now this alcohol, ketone, and aldehydes, all of them have lower priority as compared to carboxylic acid. So the parent name here again belongs to the carboxylic acid functional group. So you have to start numbering from the carboxylic acid. Now at 3 we have a hydroxyl functionality or a substituent. At 4 and 6 we have oxo. Aldehydes and ketones both are named as oxo in the presence of carboxylic acids. So it's a 3-hydroxy 4,6. Now because we have 2 oxo, you cannot differentiate between ketone and aldehyde in this case. So it's a 4,6 dioxo, and because we have 6 carbons in the chain, so it's a hexanoic acid. Now a question arises, if we name both aldehydes and ketones as oxo, or when they are considered as substituents in presence of carboxylic acid. So if you are given this name and you are asked to draw a structure for this IUPAC name, how would you know that this dioxo is for 2 ketones or it is for a ketone and an aldehyde? how would you differentiate between a ketone and an aldehyde if both of them are written as oxo? So it's a simple, in a simple way you can differentiate between the two. So you have 4,6-dioxo. Now you don't know whether both of them are ketones or one of them is an aldehyde. So the first thing you need to see is the number of carbon atoms in the chain. So it's a hexanoic acid. So it means that it has 6 carbons in the chain. And then you see the positions of the two oxo groups, right? So if one of them is at 6 and the total number of carbon atoms are also 6, so it means that one of these oxo group is the last carbon of this carbon chain, and an aldehyde always happens to be at one end of the carbon chain, because you cannot have another carbon after this carbon, you will have a hydrogen here. So if you have a 6 carbon chain and one of the oxo group is at 6, it means this oxo at 6 is an aldehyde, and this oxo group at 4 comes somewhere in the center or in the chain, so it's a ketone. If we have a molecule like 2,4-dioxohexanoic acid, so 2 and 4 both come in the middle of these 6 carbon atoms. So both of them would be ketone. In that case, one of the oxo would be here and the other here. So both of them would be ketones. But if one of these oxo group is at the terminal carbon, and how would you know it's a terminal carbon? From its position and the total number of carbon atoms in the chain. So from here you know that one of them is an aldehyde. So this if you have a dioxo group substituent, then you can find out if one of them is an aldehyde or both of them a ketone from the total number and the position of the oxo groups. Now we can have more than one carboxylic acid functional groups in a chain. You can have this carboxylic acid at both ends of the carbon chain. So in that case, again, a prefix di is used before oic acid, so it becomes a dioic acid. And in such cases, the last E of the corresponding alkane or alkene or alkyne is not replaced. So you write the name of the corresponding alkane or alkene in full with E, and then follow it by dioic acid. In such cases, numbering will be decided by the positions of the double or triple bonds first, and if they cannot decide the direction of the numbering or they are not present in the chain, then by the position of the substituents. So let's see some examples. So we have this molecule with 2 carboxylic acid functional groups at the very ends of this carbon chain, and it has 1, 2, 3, 4, 5 carbons. So it's a pentane dioic acid, and you see pentane is written in full, including this E. So it's a pentane dioic acid. If we have a double or a triple bond in the chain, like we have a double bond here, then the numbering will be decided by the position of the double bond. So you have to see from where this double bond is the closest. So you start from here and the double bond is at 2. If you start from here, the double bond is at 3. So the correct direction of numbering will be to start from the left hand side. So this will be your carbon number 1, 2, 3, 4 and 5. So it's a pentene dioic acid, but you have to mention the position of the double bond. So it's a pent 2-ene, and ene is written in full along with this E and followed by dioic acid. If you have substituents in the chain, so now you see you have 2 hydroxyl substituents in this 1, 2, 3, 4, 5, 6, 7 carbon chain and 2 carboxylic acid. It's a heptane dioic acid, but the direction of the numbering will be decided by the positions of these 2 hydroxyl groups. So from left hand side they are at 3 and 4, from right hand side they are at 4 and 5. So from left hand side they have the lowest numbers or positions, so you start numbering from the left hand side according to the positions of the hydroxyl groups. So it's a 3,4 dihydroxy heptane along with E followed by dioic acid. If we have a double bond along with the same substituents at the same position with the same carbon length, so we have this almost similar molecule like here with 7 carbons, 2 carboxylic acid, similar positions of the 2 hydroxyl groups, but now we have a double bond. So remember, the direction of the numbering will be decided first by the position of the double bonds or the triple bonds and later by the substituents. In this case we did not have any double bonds, so the numbering was decided by the position of the hydroxyl groups. But here we have a double bond and substituents. So first you have to see from where this double bond comes earlier, or it's the closest. So from the right hand side it is the closest, it comes at 2. So you don't have to bother about the position of the substituents in this case. First you have to see the position of the double bond. If it cannot decide, then you can decide from the position of the substituents. But here the double bond can decide, so we start from here and the double bond is at 2. So again it's a 4,5 dihydroxy. You see the positions have changed now because the direction of numbering has changed. So it's a 4,5 dihydroxy now, and it's not a heptane dioic acid, it's a heptene dioic acid because of the double bond, and you have to mention the position of the double bond. So it's a hep2ene. Ene is written with E and followed by dioic acid. If this carboxylic acid is attached to a cycloalkyl ring, then the name ends with carboxylic acid and it is preceded by the name of the corresponding cycloalkane. So if the carboxylic acid functional group is attached to a cyclohexane or a cyclohexyl ring, then the name is cyclohexane carboxylic acid. We have a cyclopentane ring here attached to a carboxylic acid, but this cyclopentane ring is also substituted, and you see from its point of attachment to the carboxylic acid, this hydroxyl group is at position 2. If this is carbon number 1 for the cyclopentane ring, this would be carbon number 2. So it's a 2-hydroxy cyclopentane carboxylic acid. Alright, so 2 is for the position of the hydroxyl group with reference to the point of attachment of the cyclopentane ring to the carboxylic acid functional group. Here again we have a cyclohexane ring attached to a carboxylic acid and with 2 substituents. So at position 1, this is position 1 because this is the point of attachment of this ring to the carboxylic acid functional group. So at position 1 we have a fluorine atom or group attached, and at position 4 we have a methyl group. So we have 2 different substituents and we have to mention them or write them in alphabetical order in the name. So it's a 1-fluoro-4-methyl cyclohexane carboxylic acid. If this carboxylic acid is attached to a benzene ring, so if we have a simple benzene ring attached to a carboxylic acid, then the complete name of the molecule is benzoic acid. So this is the structure of benzoic acid. Now this aromatic ring could also be substituted at different positions. So with reference to the point of attachment of this benzene ring to the carboxylic acid, we have a hydroxyl group at position 4. So if this is 1, the hydroxyl group is at position 4. So it's the 4-hydroxy benzoic acid. If we have 2 different substituents at different positions, then we can name it as, like we have a methyl group at position 2 and a hydroxyl group at position 4. So in alphabetical order, hydroxyl group comes first. So it's the 4-hydroxy 2-methyl benzoic acid. This is how you can name carboxylic acids in the presence of different functional groups. I hope you have got it. Stay tuned for some more lectures in the series. Thank you so much for joining.